So this is MS112, pre-calculus, algebra class. We meet 12:45 to 2:15. My name's Clint Stanley. It's just Mr., not Doctor, so you don't have to doctor or professor me. Just Mr.'s fine. There's my office phone number and there's my email. Okay, all that stuff's on Canvas too. Email's the best way to get in touch with me. We'll talk about that more in a minute. So to be in here, you need to either have scored an appropriate score on the placement test, that Ed Ready test that we take, or have taken MS100 and scored appropriately in there. If you have concerns about if you're in the right class or something, you can come talk to me after class and we'll check on it. Most of you are. Usually this class, the computer system's pretty good about not letting you get in here if you're not supposed to be. If you're concerned, let me know. Okay. Let's see. Do all the rest of this boring syllabus stuff, sorry. You can use a scientific calculator on testing here. You don't have to if you don't want to. And on one of the tests, we'll be doing some graphing stuff, and it's stuff that you need to know without graph calculator, so graph calculator not allowed them. Our textbook's just called Algebra and Trigonometry. Stuart, you don't have to have a hard copy of the book if you don't want one. Talk about that a little more. What you do need access to WebAssign. That's the program, the software that we'll use to do all of our assignments for the class. And get access to that, it's really easy. Okay, there's just a link on Canvas that I'll show you in a minute, and you just click on the link and it gets you in the right class and everything. You can access WebAssign through Canvas. How that works, you should have got an email thing called the First Day program. With that, it just charges it to your student account. A little bit cheaper than it would be if you went to the bookstore and had to buy something. Bookstore. It's automatic and it's a little bit cheaper, so that's a really good thing in my opinion. And with that, you automatically get access to the electronic version of the textbook, so that's fine if that's all you want. You don't have to purchase a hard copy unless you're just a person that likes looking at the hard copy of the book. All right. Questions on materials? Okay. For the class, our grade comes from. We'll take 3 tests during the semester. Each one of those will be 100 points, so that works out to be 75% of the grade. And assignments in WebAssign, yeah, 100%, 5% of the grade. And we're going to do an optional final in here. What that means is if you're happy with your grade after we take test 3, you're finished. If you need to improve your grade, then you have the option of taking the final exam. And if you score higher on the final than you did on one of your other tests, that final exam will replace your lowest test grade. Kind of gives you a chance to redo. Don't do well on one of the tests once. That how that works? Does it? Right. So here's some stuff I expect from you. It's not anything unreasonable, and I don't think. The main way I'll communicate if we need to make some kind of class announcement will be through the announcements on our Canvas course. So make sure you're checking those. Does it automatically send you an email if somebody posts an announcement, or do you have to sign up for that? It's automatic? I think it's automatic. If we have anything that's an emergency, like 15 minutes before class and I'm in a car accident, not going to make it or something, right? So it's real last minute stuff. I can go through the system and send whatever phone number you have in the system a text message. So if we have an emergency, you might look for that, but I'll let you know. I'll say, hey, this is Stanley from math. What in the world you're getting a text from? Hopefully we don't have to use it. Check your JSU email. Now, a lot of people don't use that as their primary email, but get on that. You send me a message, if you will. Like usually your name's on there automatically. I got to include your name. Usually your name pops up automatically, but you will let me know what class you're in. Makes it faster for me to respond to you. I can look it up if I don't remember. I can look it up and see what class you're in. Because I'll get questions like, hey, is our test today? And I got to know what class you're in to be able to answer that. Okay. Try to stay on top of assignments. You know that. Try not to procrastinate. I know that's a lot of our nature. I have that too. And as soon as you start realizing you're having trouble, if you do, realize you're starting to get behind or having trouble with something, get help then. Don't wait. We've got all kinds of resources we can use to help. Questions on any of that? Good. All right, now we get the super boring stuff. All the stuff we have to have on our syllabus. We've got electronic communication device policy. Here's the short version of that. On a normal class day, it's not a big deal. If you need to answer a text message or whatever, have your phone on the desk. I don't care as long as you're not disturbing everybody. Your phone rings on accident during a normal class, just make it be quiet after that, and it's not a big deal. The only time it is a real big deal is on test day. Test day, we can't have any phones, any smartwatches, that using any of that stuff on test day. It's automatic F and has no right of appeal on that university-wide policy. Normal day though, it's not a big deal. But try not to let it be a distraction. Okay, no, math's not everybody's favorite, and it'd be a lot more fun to be playing Candy Crush or something, doing algebra. Try not to be. Okay, questions on that one? Attendance. Technically, we have an attendance policy in the math and computer science department. Supposed to be at 80% of class meetings to get credit for class, but we're in the middle of the pandemic, so we really don't have one right now. Just common sense. You want to be here as much as you can. You're paying to take the class, or somebody is. So you want to be here. The easiest way to learn the stuff, come to class. So be here as much as you can, but have times when you need to miss. Best judgment. I will take attendance, but it's not for points or anything like that. We'll run into issues probably this semester, so just keep up with you. So like if I know somebody hadn't been here all week, then for the last couple of weeks, I can check on you. Questions on part? All of our assignments for this class will be submitted through WebAssign. I'll show you the link where to get access to that in Canvas shortly. Right now, on the next one on testing, right now the plan is when we take tests, we'll just do paper tests in our classroom. COVID goes crazy, then we might have to adjust. In 2020, one of the ways we tried to mitigate that was that we would schedule a time in one of our really big classrooms, and we'll have a class this size with this many people, what we would do is we would schedule 2 different test days, and only half of us would come one day, half of us would come the other day. So we can do that if we have to. And beyond that, we'll have to figure out some other plan. So Hopefully we don't get to that point, but just in case, know it's a possibility. That's why we're listed as blended, just in case. Plans to try to do it as normal in class as possible. Questions on assignments or tests? If you miss a test, if you know you're going to miss a test ahead of time, it's nice if you can let me know and we can talk about it before test day. I know sometimes that's not possible, so that's okay if you can't. If you miss a test, I can let you take a makeup if you have a valid, documented reason. Okay, so two parts to that: valid and documented. Now I realize there are times when you have a valid reason for not being here, but you can't really come up with documentation to document. Sometimes you have crazy stuff going on in your family and things like that. I get that. Okay, the idea behind documented with examples of documentation would be like a doctor's excuse or funeral program or an obituary or traffic accident report or court papers or things like that. If you have to miss a test and you can't have documentation, it's okay. What we'll do is we'll let final exam take the place of that missing test. The optional final take care of it. It'll do that for one test. So what we really need to avoid, don't need to miss more than one test without a documented. That would be a disaster scenario there. Questions on that part? And I got a little bit more on there. If you're taking the makeup, we'll take it over in the basement of the library and testing services. Give you all those details if you need. Okay. Email is the best way to get in touch with me. Or the next best is a Canvas message. That's almost as good as email. It would be just as good, except sometimes Canvas is a little glitchy, and if it's something you need to know in a hurry, sometimes it takes 20 or 30 minutes before I get the message. You can send it on Canvas, but if you need to get in touch with me quickly, email is the best way. It's not super pressing for time. Canvas is. I am usually really quick to respond to email, especially if I see it's something important, like time sensitive. As long as it's not like the middle of the night, to get back to you really quickly. Just be aware that like if you send me a 2 a.m. email, it'll probably be the next day before I answer it. Or occasionally on the weekend, maybe I'll be slower. Usually not. Possibly. I do have an office phone, but hardly anybody uses it. But anytime anybody does, it's when I'm not in there. So it's better to just send me an email because I can get it on my phone and wherever I'm at. All right. Academic dishonesty. Don't cheat. It's important. I have 2 degrees from here. It's important to me that those have some type of value, that they're not just meaningless pieces of paper. So academic integrity is an important responsibility for me because of that. And assuming most of you, if not all of you, hope to have a degree from here, want it to be worth something as well. It's really not just you personally don't cheat. You don't want the other people around you cheating. Because what happens is they'll get off out into the job market and employers will realize, oh, hey, they graduated from JSU and they don't know what they're doing. And then when you go to apply somewhere with a degree from JSU, they think you don't know what you're doing. Not necessarily just in algebra, just in classes in general. Don't cheat. That's it. Here's our COVID-19 statement we have to have. It's already changed. I can say. I'll just go ahead and put this in here. So right now we have to wear masks. Whenever it gets to the point where it backs off, like it was right before, like the beginning of the year, it'll be up to me what we do in the room. So in that case, strongly recommended. That will be our issue. But right now, we're required. That's it. Questions or concerns on? There's contact information for the Student Success Center. There's also a link in Canvas. Tutoring help. Need help figuring out how to do that? Just let me know. There's extra tutoring information. There's contact information for disability resources. That I need contact information for veteran services. There's that. And if you need contact information for Title IX concerns, all that information. All in the syllabus. And I think you have a link on Canvas to most of it. Then the last part of the syllabus you probably really don't care about. It's just where we keep track of how we're doing as a department. There's a few of the things we learn in the class, and then we figure out how good of a job we're doing actually teaching you. Questions on the syllabus? Anybody? Okay, let me look at our Canvas class really quickly, show you where some stuff's at. So here's our home page. Hasn't been up long. Okay, if you looked for it yesterday, it wasn't there yet. Here's our home page. On the home page, I've got two things for you to get to really quickly. If you need to see if I'm in my office before you stop by, I've got my office schedule on there. It'll eventually pop up. So here are my classes when I'll be busy, and then here are my office hours when I'll be in there. If you need me some other time, send me an email and we can make an appointment and figure out another time to meet. That's no problem. A quick reference from you. Okay, I don't know what your schedule's like today, but most of my office hours worked out to be on Tuesday and Thursday, so maybe that'll be good for this class. But again, I can make time later in the day or whatever if we need to. If you just send me an email, we'll make an appointment. That's there, and then need to get back to the syllabus. The link to the syllabus is well, so all that stuff. Been slow. There it is. That's what we just went over. So the next place we're going to look is under the modules tab. Let me go to student view so you don't have to look at all the extra junk on my screen. So to get access to WebAssign, all you have to do is click this link. It says WebAssign access. It'll get you in the right class and you'll be ready to go. Not too tricky. And then anytime you want to work on assignments, you click on that link and it gets you logged into WebAssign. There's some generic Canvas stuff, FAQ, and a link to those policies and all that. But something that can be helpful, I want you to be aware of. Down under that, I've got some videos I've made in the past, labeled with their topic or what section they go with. So if you're working on assignments and you're a little confused about part of it, then check this list and see if there's already a video on there about that. They're short. I made these. These are short and to the point, just example videos. And as well, I have our class meeting screen recorded. I'll put them in their own section. But the little example videos there, short and to the point. Questions on any of that? about it to look at in Canvas at the moment. Okay. All right, so next thing on the list, let me take attendance really quickly. These first few days while the roster's still kind of up in the air before the add drop date, I'll call attendance. After that, I'll just pass around a sign-in sheet so you don't have to listen to me take attendance every day. If you go by something other than what I have on my sheet, or if I say your name incorrectly, just let me know the correct way to say it, or let me know what you go by, and I'll get it fixed. Okay. Slade Alexander, Katie Allen, Kirsten Baldwin, Elijah Bone, Matthew Caldwell, Corey Crump, Christina Culliver, Mitchell Etheridge, Sarah Frazier, Joseph Fuller, Noah Fuller, Miles Garner, Hannah Godfrey, Morgan Hayes, Jasmine Hines, Kyle Holt, Shia. Yeah, I probably butchered that real bad. I'm sorry. Shia. Oh, yeah. Okay, that makes sense. Sorry. Leah Keith. Okay. Kalea. Okay. I should know better. Paulina Lindbergh. Emma McCreelis. Reagan Peak. JT Pennington. Omeron. Pope. Omarin, yeah, okay. Pope, okay. Brock Recksteiner. Close. Garrett Render. Sorry Rivers. Brooklyn Shipley. Omar Sims. Osiris Smith. Elizabeth Stevens. Grady Trantham. Ansela Underwood. James Womack. Did I miss anybody? All right. So one thing that we have another benefit in this class. We do have a supplemental instruction leader this class, so we'll have session available to us. Are you okay? Sorry. Okay. I'll let you go ahead and sing if you want to. Anybody done SI for class before? Oh, okay. That's real helpful. Yeah, it can be. and need to get you access to Canvas. Okay. All right, so good opportunity. Not all the classes get that. Try to take advantage of it. Okay. All right, so we do have to do a little bit of math today. But before we do that, okay, it won't obviously not a whole class because we have to go through all this stuff. Before we do that, something I typically like to do on our first day, everybody getting stuff out now. Everybody's all right, just staying packed up in case you just got there. I know, I'm sorry. Yeah. Math class is just mean like that. All right, so before we do that though, okay, something non-math related, unless you want it to be. I know it can be intimidating when you have a class this size and you have a lot of people you don't know in there maybe. I know it can be intimidating asking a question, okay, if you don't understand something, or just asking a question in general. For some reason, we have like this psychological thing where if we don't understand something, we think we're the only person in the room that didn't understand it, when really probably almost everybody else in the room didn't understand either. So to help us try to get over a little bit of those nerves, one thing I typically like to do on the first day of class is give you the opportunity to ask me anything you want to ask. Okay? You can ask me anything you want to know. Okay? It can be about the class, it can be about JSU, it can be about me, whatever. Okay? Any question you want to ask, and I will do my best to answer. I will answer almost any question you ask. Okay? Let me think. You got anything? You got one? It's similar in that it's online assignments to work on. It's different in that it's not mastery based. Just do each problem. We will look at it. I think we'll wait until Tuesday. We'll go and spend some time looking at how WebAssign works for the that have not used it. How many of you have not used WebAssign in the class? A bunch of you. Okay, we'll definitely take some time and go through what it looks like and how to answer some questions on Tuesday. Anybody else? Anything you want to ask? And if nobody comes up with anything, we just have to be awkward for a while. So might as well come up with something that it can be silly, it can be serious, doesn't matter. Yep. Okay, so the way it'll work out, we'll have about one a month. So it'll be a little while. I'll try to get you the date soon. I don't have those laid out just kind of like to see how things are going to go a little bit first. Least favorite thing in this class, or just least favorite thing about in this class? I get tired of doing quadratic equation. It's not that I don't really have anything against it. I get tired of it. That would be my answer. Yep. It depends on the person. Yeah, it's not. We don't have one that's definitely hardest for everybody. Like questions? No, it'll be more than that. It'll be closer to 20. It might not be all the way to 20. Some of them, but it won't be so long where I don't try to stress you with time. I don't try to make time a factor when we No, it's just work out the problems on paper. So, well, see, that's good. Don't make a face. That's good because then if you make a mistake, then I can give you partial credit. Partial credit. If you think multiple choice is better, you've never had a real hard multiple choice test. Because what you do, I mean, is you just go through and you think about all the little mistakes somebody could make all those answers. So, does that help? Well, so D is technically passing. Some of your majors, depending on what your major is, some of your majors require you to have C. A major. You get credit. You get a class credit, like a D or better, which is it's 60%. Any more? Everybody needs practice. It's been about the class so far. Nobody wants to know anything about me. I look that boring. I'm 36. What was your guess? Do you have a guess? Yeah. You didn't have a guess. I just wondered. 25? You thought? It's yeah. You got mask fished. Ma'am. Well, I started teaching here as a graduate assistant 2012. So after that, finished that in 2014. I started here as an adjunct. So going on 8 years. Yeah, y'all get started up a little bit. I like the SU. I mean, I wouldn't mind going somewhere, but I'm not looking to go somewhere. I went to school here too, so I've been here a long, long time. I went to Gaston, Gaston. It's a little bitty 1A school in Etowah County. You know it? Just want you shaking. Oh, yeah, I know, but do you know the school? That's why you're shaking your head. I didn't know. Yeah. You don't get the opportunity to just ask anything you want to very often. I graduated in 2004. Yes, we should get out of there. Yeah, we should. Yeah, we're 12:45 to 2:15. Yeah, we'll out of there. Depending on how long you take to ask questions. So the more questions, the faster it gets over. Is what I'm saying. Well, we need from varied people though. Gotta. Yep. Anything that's scientific, just so you got parentheses and it's easy to do exponents and things like that. You just request an extension. And it doesn't need to be a pattern, but you can just request an extension, and we'll look at that on Tuesday too. Just request an extension on WebAssign. I'm sorry, I didn't hear. We'll have an assignment that goes with every lecture. I try not to make them overbearing. I don't know. It's a hard question to how much is hard. It's a hard question. So we'll Tuesday we'll look at the ones we've got up so far. I've got the first three. Not always. Especially not an hour and a half class. That's a lot of lecture to sit through. But a lot of the lectures is just us working problems. The actual lecture material is pretty brief. I can't. This side's kind of cooling off. Going on. We need, I think, 2 more. If we get 2 questions from people that haven't asked one yet, then I'll be happy with that. So, I have my bachelor's in bachelor's of science in mathematics with a minor in computer science from here. I have my master's in mathematics. Favorite type of math? I do really like algebra, but my favorite class to teach here is probably statistics. Those two. Anybody else? I'll take that. All right, so a little bit of math. Hopefully, this stuff is review to you. At least if you don't remember how to do it, then hopefully it'll come back to you. You at least ring a bell and you'll know that you've really seen stuff. The as far as where it comes from out of the textbook, and it's how the assignment's labeled. This is out of the P chapter, before we really get to stuff that are considered 112 topics. Yep. Well, it would be good to have a notebook for your notes and stuff, but just however you want to do it, it's just your own style. There's nothing that's required necessarily. So in this section, we want to deal with exponents and radicals. So not the whole section. We're just going to review some of the properties. So let's think about a few properties of the exponents here. This number. We have something like x to the n times to the m. So whatever, it doesn't even necessarily have to be a variable here. We just have some number that's the same, or we could have a variable that's the same. But then they have different exponents up here. We want to multiply them together. We've got a rule for what we're supposed to do with the exponents. Anybody remember what we do with the exponents? We add them, yes. And the general way we would write that down, say x to the n plus n. So we've got x squared times x cubed. Well, let me do x to. We add those. I have x to the 2 plus 4, so 2 plus 4 is 6. If we're multiplying two things, we've got, or it's the same thing, okay, both x's have different exponents. We're multiplying, then we add the x. So we could also have the situation where we're dividing. What a fraction means, right? A fraction division. So similar situation, we're just dividing instead of multiplying. Remember what we do with the exponents in that situation? We subtract. Good, yeah, we subtract. And if we're adding, it doesn't matter what order we add numbers in, but when we subtract, it does. So we'll have x to the, which exponent's going to come first? n, yeah, the top one. So x to the n minus n. So if we put some numbers on that, squared, then when we subtract 5 minus 2, so hmm? One more here, more property. This list. What do you have? I don't want numbers yet, sorry. What if we've got a term that has an exponent, then we're raising that to a power? So we would multiply, yeah, a rule there. If we have a term with an exponent and we're raising to a power, we multiply. That's right. So this one we would have x to the n times m. So if we put numbers on that one, we got x squared, and we want to raise that to the 5th power, the x to the 2 times 5, or 5 times 2, x to the and got one more thing to look at. I'm not, well, don't have to call it another property, but if we have this situation. So what's going on here is we have x and y are multiplied, their product, and we want to raise that product power. Anybody remember what our answer is going to be on? Similar to what we just did. Okay, so let's think about this. So one thing to talk about. So let's look at this y. This y has an exponent. What's the exponent on just the y? 1. Yeah. And the exponent on just the x? 1. Yeah. So we've got x to the first, y to the first. So we can really use our rule from the last one, property number. We multiply the exponents on this thing. We raise that to a power, we'll end up with m times 1, y times 1. So a lot of times where people forget that rule is when we have something like 2x raised to the 3rd power. The way we're supposed to do that one, you're supposed to find 2 to the 3rd power times x to the 3rd power. And 2 to the 3rd power, what does that mean? Like we're trying to calculate that. What do? We do 2 times 2 times 2, right? It says we multiply 2 by itself 3 times. 2 times 2 times 2. So that one we would get 8. A lot of times people forget to raise the 2 to the 3rd. That's this situation, right? It's 2 to the 1st times x to the 1st. Questions so far? Look back at any of it or anything? Like you're distributing the power. Yep. The another place where you have to be a little bit careful, is this is our rule if the thing inside the parentheses is a product, if everything's multiplied together. Which you can't do, you can't just raise both to the power when you have a sum or a difference in it. So if we have this, we've got x plus y, not times, then that is not x to the m plus y to the m. We'll talk about how to do that. Refresh our memory about how to do that. That's because we can't use this property because we have a plus sign, we have a sum, or if you had a minus sign, this idea only works when it's a product. Or, well, actually, or a quotient of fraction. Okay. Other questions? Okay. Let's think about something else with exponents here. What if you have a situation like this? So we got a 1 on the top of our fraction. On the bottom, I got x to the negative m power. Lots of times we don't want to leave negative exponents. We don't consider that simplest form. So you may remember what we can do to get rid of the negative exponent. I'll say one more time, sorry. Move it to the numerator. Yes, we can move it to the top, right? Move it to the numerator. I made this one a little bit tricky because so what we're doing, okay, the long version is we're moving that term to the top, leave us a 1 on the bottom. We don't normally write it like that. We would just write it. Normally, when you think about that property, you do it the other way around, right? It works the other way around also. Different color here. Maybe. Sorry. Got my screen on this stuff. So usually when we're thinking about this property, we think about starting here. We want to get rid of a negative exponent, then how do we change that exponent to positive? So this one, since we don't have anything written, really has a denominator of 1. So if we wanted it to be written as x positive n exponent, what do we do? It's the same idea as the other one. We're just going the other direction. Where does it need to go? To the bottom, yeah. Bottom. Bottom. Same thing. So it works both directions. So usually when I'm just informally talking about this property, I say if you want to get rid of a negative exponent, you move that term to the other side of the fraction bar. If it's in the bottom, you move it to the top, move it to the bottom. Rearrange. Okay. Yep. Yeah, you can definitely think about flipping it. When that gets a little slightly trickier to think about just flipping it, is if you have we want to get rid of our negative exponent, then we've got to take that x to the negative n term and move it to the top. So we end up with n. So it doesn't look like we've just flipped it. we don't want to move the 2 because the exponent on the 2 is a positive 1, so it's happy. Okay, let's see if we can put some of these together. See if we can simplify some expressions. Let's simplify. Ooh. Okay. So we want to use our properties we've talked about. We want to write this thing as simply as we can, and with that in mind, we don't want to leave any negative exponents. So you may be able to see everything we need to do all at once. Probably not everybody see all that, so we'll take it one step at a time. Anybody see anything we can do? Take one step. Yeah, it does turn out. Yeah, so yes, technically you're right. So what we've got here, how we got this term times this term. So if we're going by our rule, what should we do with our exponents? We should add them, but since this one's negative, then yeah. What we end up with there, if we simplify one step, on the top we have the 9 plus a negative 2, or 9 minus 2, whichever way you want to think about that. And see something else? Yeah, they cancel. So yeah, we informally call it canceling. If we're thinking about our properties, how we're doing it is we're taking x to the 7th and x to the 1st, right? Doing 7 minus 1. If you want to think about one of the x's canceled, a little more informal, but that's works. You may think about doing something different first. Think about that's perfectly fine. That's perfectly fine. We could have so with a negative 2 in the top, so it'll be positive 2 in the bottom. And on the bottom, we've got exponents of 1 plus 2, so third. And we've got exponents of 9 minus 3, so 6, so that's fine. There's not just one way. As long as each little step you're taking is sound, get there. On that one? Okay. Those are our exponent rules. We did that one, putting most of them together. Let's see, what did we didn't raise a product to a power. That was so we didn't use this rule. The only one we didn't use on that one. The other part of this section, so we've got our exponent rules we wanted to review, and then the other part, we want to talk some about radicals. Kind of have two pieces to So what's a radical? Math class. Can I think of an example? Bringing the terminology back to memory, hopefully. Cool. What about square root of 2? That would be one. We lump these things where we use this root notation. Here we're taking the square root, so we'll call that a radical. Got a number underneath the well, two things really. The first thing we want to point out, radicals, hopefully this review, that if we have, let's think about like, remember what we call that one? If we've got a 3, you can say third root, there's nothing wrong with that, or cube root. So when we had the square root, we have like an implied 2 there. We're thinking about that number being a 2, we don't write it down typically. So these numbers, anybody remember what those are called? They're part of the radical, they have a name. Call that the index. The index of our radical. So the thing we want to talk about here is if we have something like cube root of x. So we said that's a radical, so we would say this one's written with radical notation. We've written it down as a radical. So we've got another way that we can write an expression that means the same thing without using a radical. We can use something else. We can use an exponent. And if we take a radical, change it to an exponent, it ends up as a fraction. We have a fractional. So cube root of x turns out to be the same thing as x to the 1/3 power. So those two expressions mean the same thing. The radicals are just ways we represent fractional exponents. And the kind of the form they take is if we have something like this. So I've got the radical, I have an index of n, and then the thing underneath my radical, the radicand, you don't have to know that. Thing inside the radical has an exponent of m. So if we change this to fractional exponent form, we get x to the m over n. Maybe I should do different colors there. The index goes in the denominator of our fraction. And then if we have exponent with thing underneath the radical, that goes in the numerator of our fraction. The same thing was true on the first one, because what was the exponent on the x? 1, yeah. That was a 1. That with a 1 on top. So what if we go the other way? What if we had something like x to the 2/7 power? What if we want to write that in radical form? What would the index on our radical be? So now we're going to have a radical. It would be 7, yeah. So we would 7th root. And then what would be underneath the radical? X to the second x squared. So we just want to be able to go back and forth. We want to be able to switch from exponent form to radical form, from radical form to exponent. Sometimes, usually, radical form is more natural for us to think about. And sometimes exponent form is easier for us to do operations with, because then we can use all of our exponent rules. Add exponents. That's a little trickier to deal with than radical form. Be helpful going back and forth. And one last thing. We want to be able to simplify radicals. So let's look at one that we could simplify. Three. I would say this radical can be simplified because what's our index on this one? It's not written, but it's a 2 only. Yeah, 2. Square root, right? That's the index of 2. And we have something under here that has an exponent that's bigger than that. That's an indication that we can simplify. One way we learn to do that a lot of times is we'll say, okay, it's a square root. Do you see any factors, things that multiply to give us x cubed, that would be a perfect square? So on this one, maybe you would see that x cubed is x squared, which is a perfect square times x. And a lot of times we would say, okay, well, since this is a perfect square, we can find the square root. And we're being a little lenient here, but we would say square root of x squared is x, and that would be what we have left over. Maybe with numbers would be better. There we got the square root. So we're looking if we have any factors of 8 perfect squares. 8 we can think about as 2 times 4, or 4 times 2. So 4 is our perfect square. We can find the square root of that. Square root of 4 is 2, and then that leaves 2 underneath the rest. Nothing wrong with thinking about it that way. That gets a little harder when the exponents start getting bigger, because I know several perfect squares. I have a pretty good list of those in my memory. I know a few perfect cubes. If we start trying to simplify like a 7th root, I don't know very many perfect 7ths. So thinking about it that way is a little bit limited. Another way to do the same thing, so let's do square root first, and then we'll do a bigger one, and I'll show you why. So square root of 1/7. I want to simplify this. So instead of looking for perfect squares, another way to do a very similar approach, a little bit more, in my opinion, is to take this number, this 27, and break it down into its prime factors. We're going to factor it down as much as we can. So you've probably seen this. You might not do a little factor tree. When you think about what times what gives us 27, anybody think of it? Yeah, 9 and 3. 3 we can't. 3 is just 1 and 3, so we can't really break it down. We don't have to have ones. 9 though, 9 would be 3 times 3. Get those little branches all the way down until you get prime numbers. So here we've got 3 times 3 times 3. We could rewrite square root of 27 as square root of 3 times 3 times 3. And once you have it written that way, simplifying is pretty easy because our index, again, we don't have it written there, but our index on this one is 2. So you can think about our rule here is anytime we have 2 of something, we can bring one of them out. Anytime, so because our index is 2, anytime we have 2 of the same factor, we can bring one out front. So here we've got 2 3s, so that means we can bring a 3 out front. That'll leave us with 3 square root of, we still had 1 that was left in. So when that's more helpful. Yep, sorry. Is that good? When that seems to be more beneficial is when our index gets bigger. That one might actually take a little longer to do it that way if you know your perfect squares pretty well. Right? Because you could just say that was 9 times 3, square root of 9 is 3. And when thinking about it that way is better. And we have like a fifth root of 250. So what we're looking for in order to be able to bring a factor out front, we need to see if we have any factors that we have 5 of. So we can take 256, do our little factor tree. That one, okay, it's kind of big to be doing head, but you can see it ends with 6, so it's even. So if we divide it by 2, and we can use a calculator in here if we need. That's 2 times 1, 8. 128 is even again, so we can divide it by 2 again. So that's 2 times, am I? 4. Factor tree gets a little messy on this one because I picked something with all 2s. 2, 32. 15. I should have drawn my branches a little smaller. 8. 4. So how many of those we got? Let's see. 1, 2, 3, 4, 5. So we know we can bring one out. 6, 7, 8 2s in there. If you really wanted to, you could figure out it that way, right? Yep. And we need 5 of them to be able to bring one out because our index is 5. So, oh, let me get a different color here. So 1, 2, 3, 4, 5. We only have 3 left over, so that's not enough to bring out. We would do 5th root of 2 times 2 is 4. 4 times 2 is 2 times 50. That will get you through 11 of the 12 problems on that assignment. We'll save the last one beginning at Tuesday. It's not due till next Thursday. So. I told you I'd let you out early, so make sure I do.